Hey everybody, welcome to Leon's Chainsaw Parts and Repair. So I wanted to cover some stuff that it can be confusing, and how you approach or how you understand the way a two-stroke engine works can really dictate how you approach trying to do repairs. So I've heard quite a few times folks refer to compression and potential compression loss as being anywhere within the engine, and that's not the case. When you're measuring compression, just strictly compression, you thread your gauge into the spark plug hole and you roll it over, usually by about 6 pulls. You're as good as you're going to get. You're only measuring the sealed portion of the cylinder that the rings are sealing up. I don't know if I'm going to be able to get this to go in without using a ring compressor. There we go. So you've got your stroke. Come on, baby. Your engine stroke, okay? So assuming that this was installed on an engine, as it pushes up and it seals the cylinder entirely, you're going to be measuring the compression of this sealed assembly. Alright? Now you note there are transfer ports here. This is how fuel and air are drawn in there. Okay? So when are you going to actually get your compression reading? It's when the rings get past those transfer ports, which are going to end roughly just about in the middle of the muffler port here. Okay, are you guys tracking? When the rings get to that edge right there, when the top ring gets there, you start measuring compression. That's it. Now there's other stuff that involves a crankcase, but your measure of compression, truly compressing and burning, it's all going to occur past those transfer ports, because once the rings pass, it's not drawing any air, it's not drawing any fuel. What's in there is what's in there. And just before top dead center, that ignition's going to fire the plug, and boom shakalaka, we have a revolution. But I think that gets lost on folks because, I mean, it's connected. Okay. And yes, the integrity of the rest of this matters. It absolutely matters. But it's how it matters that you've got to keep in mind. So, purely measuring compression, why do you do that? Well, I think most folks who've messed with two-stroke engines know there's a minimum amount of compression. Any engine, there's a minimum amount of compression for it to actually run, and run properly. These things, if you're at 115, you're just right on the knife's edge. 120 is okay, and that's a normal range for used saws, 120 to 130. That's where you see a lot of used saws fall. Some are higher, hopefully not lower. I mean, typically if they're lower, it's because there's a problem. But that's just to control what's happening right up in here and make it run right so it can generate power. So where do leaky cylinder gaskets, leaky crankshaft seals, crankcase gaskets, things like that, where does that come in? Well, that's where the leak down tests are worthwhile. That's where, not leak down, crankcase pressure testing. So when you pressurize the crankcase, you're testing the seals, you're testing the gaskets, cylinder, in this Super XL style, you've got your cylinder gasket that's going to be in there. You've got the crankcase gasket between the drive case and the crankcase here. and those two seals. That's what you're really testing. But it goes even further than that. Normally, most of us are going to block off above the reed valves, but say you didn't, you're going to have a leak past there because those reed valves don't seal. I mean, they seal most of the way, but that's why there's check valves in those carburetors, so that those crankcase pulses that make it by the reed valves don't interrupt that draw of fuel and air. I mean, imagine if you've got it pushing against, you don't want that. That's not cool. That's why those reed valves are there, and on a piston-ported engine, that's why that port is right at the exact spot where it has to be to avoid that. Now, what I said before about leak down, or blow-by, or whatever you want to call it, when your rings wear, as it's going up on that compression stroke, you can get leak down. You can get blow-by. And usually it shows up as coloration on the piston. Now, this is pretty minor. It's not, I would run this piston in a heartbeat. That's no big deal. I've seen far worse that run pretty well. But as you start compressing and you've got your fuel and your oxygen that are blowing back down into the crankcase, sooner or later that causes a runnability issue, because you need all that fuel and air to make the most power. You want it all there when that spark, the spark plug fires. It ignites that. You want that to stay there. Likewise, once it's fired, the exhaust gas, that's what's going to discolor this exhaust side of the piston, is that exhaust gas that rushes down. Now, in theory, most of it's going to go out the muffler, but if that starts introducing itself into the crankcase, that's a different set of problems. Again, you've got hot gas moving back, counteracting the flow of air and fuel in when it should be drawing in, and you're going to have a lower concentration of oxygen. So, when you're crankcase pressure testing, you're actually testing the entire engine assembly up to your block-off ports. Now, the way I do it, of course, I go in through the spark plug hole, so that's sealed. I put a block-off on the muffler, and I typically go right above the reed valve, between the carburetor and the reed valve up here, and block that off, pump it up. Okay? That gives me lots of places to test for leaks where they could be a serious problem. Cylinder gasket, crankcase gasket, crankshaft seals. Again, that, I'm going to say 70%, if not higher, of the leaks that I encounter are going to be those crankshaft seals. Now, on newer saws or different brands of saws, maybe that's not true. Maybe it's far more common where you have a split crankcase for that gasket to go bad. I personally don't find these cylinder gaskets to hardly ever do you see one leak. And same thing on the crankcase gasket over here, unless these screws have loosened up and it's sat there and rattled, then it can tear that little paper gasket, mess it up. But again, vast majority of the time it's going to be one of these crankshaft seals, and I find it to be the flywheel side one far more than anything else. But with all of that in mind, so you've got your saw, you're trying to run it, it's just not running right. Or it won't start. Let's go with that one. It won't start. Okay. A leaking crankshaft seal, that's not going to prevent it from at least trying to fire. Now, if the seal was entirely missing, maybe at that point it would completely screw up the crankcase enough that it wouldn't be able to draw fuel. But I still think it would at least attempt to fire. It'd run like crap, but it would attempt to fire. So, if you've got a saw you're working on, it's new to you, pulling it over, giving it a prime, will not fire. And you know for certain that it has a spark that'll jump a 1/4 inch gap on a tool like that, or you bust the ground strap off of a regular spark plug, and then you carefully hold it, a 1/4 inch away. If it doesn't jump that, your ignition is suspect. But say that's all good, you've primed it, you know your spark's good, pull it over and it either won't fire or just won't run at all. That's when you start considering that maybe your compression is too low. Hopefully you've looked at your cylinder, through your muffler ports, at the side of your piston. If you see big old scratch marks and gouge marks, odds are pretty good that's where your problem is. The piston is scored. And on these home lights, if the piston is done, the vast majority of time the cylinder is going to be done too. If it's light scoring on the piston, where it's just barely jacked up the ring landings or something, maybe you'll be able to clean it up, maybe you won't. That's a crapshoot. I've had times where it works, and had times where it doesn't. But, again, my saw won't start. A leaking crankshaft seal, that isn't it. A leaking cylinder gasket, unless it's just a giant gaping hole, and even then, I've seen some pretty good chunks of, gasket missing on, again, not home lights typically, but where they'll run, but they immediately just start racing to the moon because they're drawing so much air where they shouldn't be. So, saw won't start. Probably isn't that. It's far more likely to be a compression or ignition issue, if you're certain your fuel system's good. There's a lot of factors in here. But say you get that new to you home light to start, and you just can't get it to tune. It won't idle down, or it won't rev properly. That's when you can start looking at the rest of this stuff. Looking for those air leaks. And, you can tell an air leak. If the saw will not idle down, really good odds you've got an air leak. If you've got that idle screw backed all the way off, and it's still just screaming, it's almost certainly going to be an air leak. Now, where it's at, that depends on the saw. It depends on a lot of factors. How it's been used, what type of saw it is. I'm going to tell you to look at different things on a Mac 1010, potentially, than on this. 1010 doesn't have a reed valve. You start eliminating some of those things. It does have that spacer and the gaskets. That'd be something to check. But that's when you would want to start pressurizing your crankcase and checking for those leaks, because runnability issues where it won't idle down, where you do the tip test and it races or dies, but right here it's okay, and the minute you move it and it speeds up or slows down significantly, unless you've just got it just pig rich on the low side, and most saws won't put up with that for long. They just won't idle. They'll slowly die out. But when you do that tip test, that's a pretty good tell. And that can also be a tell of a bad bearing. The seal, there's always going to be a little bit of movement in these, and if the seal is not pliable, that's where you can start getting those leaks. Again, on home lights, it's very uncommon for the cylinder area to leak. You have to have had somebody just do something that they shouldn't have done, like reuse one of the newer style, full paper gaskets, the red ones. As long as they don't tear up, you can use those again and again and again. They are good gaskets, and they will hold up. I honestly think I've only ever come across one Super XL that had a leak on the cylinder gasket, and it was a chunk out down here, and I guarantee the cylinder had been off previously and it tore, and somebody gambled, I can just put it back together and bolt it and it'll hold. Well, maybe if it tears in one spot, but if it tears in two, nah, it's just going to blow that thing out, and that's exactly what it did. So that's the only time that I can recall of replacing a cylinder gasket that was, a huge runnability issue. The Super EZs, they've only got 3 screws holding the drive case to the crankcase, and then that one that's in the bar pad. That one is famous for loosening up, and then the O-ring that they use, can't seal and it'll leak. The good news is most of the time you can just tighten those back up, clean them up, put some Loctite on those bad boys and tighten it back up. But when you're running a Super EZ and it won't tune right, or it constantly is racing, and you end up with a visible residue of fuel running down, pretty good odds, and your handle's going to be loose. You're going to see this whole thing start moving separately of the engine. So anyway, I just wanted to try and take some of the mystery out of that, Because again, even today, had somebody who, was working with their saw and, made the statement that I realize you can lose compression at the seals and the gaskets and all of that, and that isn't accurate. You're going to have symptoms and you're going to have problems, but you're not losing true compression there. And I'm going to say this again. Compression gauges are notoriously bad, especially the El Cheapos. If it came from Harbor Freight or, if it's the O'Reilly's special, not to say there aren't good tools at any of those places, but if it's a $19.99, $29.99 compression gauge, be suspicious, trust but verify, whatever cheesy phrase you want to use, verify. Because what I can tell you is if you've got one that's only reading 40 pounds of pressure and you drop a little prime in and it fires, your compression gauge is full of crap. It is not 40 psi. It's way above that. It's going to be above 115 psi, likely around 120. So don't, if you get a new to use saw, throw your compression gauge on it and it's like, oh man, I got no compression. If you're pulling it over, that nice pop that you get, that boop, 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 that's more than 40 psi. If you pick it up by the rope and it doesn't immediately drop, it's got some compression. Now that can be deceiving. The rope test can be deceiving if it's a scored engine. But like this little guy. See that? I guarantee this thing has around 120 to 125 psi, because that's what these little engines do. And you saw how it was hanging there. Kind of use that as a reference point. Verify that compression gauge. Pull the muffler. Look at the piston. Very rarely, it does happen, but very rarely are you going to have damage that you can't see on the piston. If you've got a connecting rod problem, if you've got a bad crankshaft bearing, odds are good it's going to show up on the piston. When you pull the muffler off and you look at the wall of the piston, it's going to have scoring on it. It's going to have heat marks. It's going to have, deep grooves. The ring landings will be collapsed. You'll be able to see it. And again, on these home lights where they just have a chrome liner in there, usually that does it in. It's a very thin lining. It's, there's not enough there to withstand too much damage. So, anyway, hope that helps. Hope I didn't ramble too much there, and hopefully that'll take or give everybody a little bit, better understanding of what you're diagnosing when, and what's going to keep the saw from running versus what's going to keep the saw from running right. So, hopefully this helps.